In 1966, the United States lost a hydrogen bomb. Not misplaced, it was not stolen, but it was lost in the ocean off the coast of Spain. And the only person who could find it was a mathematician who had actually never been to the sea. Well, doesn't it sound interesting? An American bomber collided mid-air with another aircraft. One of the hydrogen bombs detached, fell into the Mediterranean Sea, and disappeared. The US military launched one of the largest search program and operations in the history. There were ships, divers, aircraft, and weeks passed, and nothing was caught. And every failed search made the next decision harder, because if you have looked somewhere and found nothing, where do you look next? Most commanders trusted their gut, decades of experience, instinct. It has to be around here. John Craven didn't have that instinct. He had something which was better than all of this. He gathered a room full of experts, submarine engineers, divers, oceanographers, and asked each one of them one question. Where do you think it landed? Not as a committee, individually, anonymously, everyone placed their bet. Then Craven built a probability map, not of where the bomb was, or where it was most likely to be, given everything they collectively believed. Now here is where it actually gets interesting. Every time a zone come up empty, Craven didn't cross it off as you would expect. He fed the failure back into the model. Zone cleared with 90% reliability, probability drops sharply. Zone searched in a bad visibility, probability barely moves. The map updated, the priorities shifted. His beliefs changed, but those were not random, but they were powered by mathematics. And this is Bayesian probability. You start with something that you believe, and then evidence arrives. Even the absence of evidence, you update the model and you repeat. A failed search isn't a wasted time. It's the data that reshapes every other probability on the map. And after 79 days, Craven's model pointed to a spot that most experts had written off. It was too steep, it was in a wrong direction, and it was highly unlikely. The team went anyway. The bomb was there, buried in the seafloor at 2,500 feet, exactly where the mathematics said to look. Not where the instinct pointed out, not where the experience suggested, where the updated probability said. And actuaries use the same engine actually every day. Every new claim that arrives, every new data point, you don't throw out. Your prior assumptions, you update them. Credibility theory, reserving, risk models, all Bayesian underneath. Bayes doesn't tell you what is true. It tells you how to be less wrong, that one piece of evidence at a time. In 1966, that was enough to find a nuclear weapon on the floor of Mediterranean Sea. The question isn't whether you have all the information. Nobody does. The question is, how fast do you update when the new evidence lands?